All right, good morning. Welcome back. Let's just review where we're at here. Monday, September 23rd. We are going to move on to section 1.2. Remember, we're on the pre-calc textbook now, not that old algebra book. We're done with that one. 1.2, domain and range. We talked about what those words mean a little bit last time. And you're going to get a chance to tinker around with the domain of a function and the range of a function. I'm going to have you do a couple more Desmos activities like we did last time. I hope the Desmos activities, I think they're kind of fun, first of all, but I hope they help you think about things conceptually instead of just memorizing notation and procedures. And we went over Function Carnival 1 in class, and then you were to do Function Carnival 2 for today. And I want to pull up Function Carnival 2. Most of you did it. Some of you did not. I'm on Function Carnival 2 right now. If you want to go into it, you can. I want to highlight a few things. First of all, those of you that did Step 8, sorting the cards, really well done. Notice everybody that did it except one person here did that one correctly. So I must be a heck of a teacher. I really taught you how to match up graphs and equations and verbal descriptions, or you already knew how to do that. I'll go with the I'm a heck of a teacher angle today. But let's go over to 11, 12, 13, and 14. Because this is where there was some confusion on step 11, 12, 13, and 14. First of all, 11, you guys nailed it. It says, if f of 5 equals a, what is a? Okay? So you got to understand the input and the output. In this particular situation, 5 is the input, the f of 5. So I got to find 5. So this person went and found 5 and found out that at 5, it gives a value of 8. And all of you pretty much figured that out. So, how many different values are produced when the time is 5? 1. 5 seconds only happens once. It happens and it never happens again, right? Once time is continuous unless we go back to the future, which would be awesome, but it only happens once, right? So there's only one answer for that one. So now, when we go to step number 12, we can see a few of you got number 12 wrong. So let's look at number 12. If f of a is 12, what is the value of a? Notice this is different. They're not giving us the input and asking us for the output. They're giving us an output and asking us for an input. See how that's going backwards? Okay, so let me pick out a step 12. Let's take a look at this one. Francis, do you guys see your fake names on your screen? Don't you? Yeah. I made it anonymous. I thought you guys could see it, though. It doesn't tell you your fake name?
Yeah, it does in the right hand.
Yeah, it does. Do you guys see it? Okay, whoever Francis is, don't change your screen right now. Okay, because I want to use an example. What did Francis do wrong here? Because this one's wrong.
They put the 12 as the input instead of the output.
Correct. This person said at an input of 12, the output is 11.804. But that's not what the question was asking. The question says when the output is 12, what was the value? Right? So, how many different answers could we get for this? I could move this dot over to a height of 12. That's what I wanted, right? A height of 12. See if I can get it there. I can get it really darn close. I can't quite get it there. Oh, there we go. A height of 12 occurs when? At 12 and a half seconds, right? So would 12 and a half have been a correct answer? Do you guys see any other correct answers? Or does it only hit a height of 12 at that time? 25 seconds. Does it let us stretch it out? I can't remember. It also happens, what did you say? Yeah. Doesn't it happen at 2.5 as well? Did anybody put 2.5? Yeah. Did it tell you were right or wrong? Oh, it doesn't tell you if you're right or wrong. 2.5 would work, right? What did we say? 12.5 would work? Okay. So, here's 13 and 14 is where a lot of you went wrong. So let's talk about this. Okay. Notice the disagreement amongst you people. 2 of you thought Afi was correct. 4 of you thought Iris correct. 1 of you thought both were correct, and 2 of you thought neither was correct. That's a really wide spread going on here. Okay? So let's read this again. Afi, I don't know if I'm saying that person's name right. Afi claims that f of a equals 9.3 has multiple solutions. What Afi is saying is an output of 9.3 is going to come from multiple different times. Does that make sense? A height of 9.3, the output, is going to happen multiple times. Think about being on a Ferris wheel. How many times, as you go around and around and around and around, are you going to cross 9.3 feet? It depends on how long you ride the Ferris wheel for, but do you agree if you ride it for an hour, you're going to cross 9.3? A lot. So is Afi correct? Yes. Let's talk about Iris. Iris says that at an input of 9.3, we're going to get some output A, but there's going to be multiple solutions for A. Is that true? No. At 9.3 seconds, how many times are you going to cross 9.3 seconds? 1 time only. And at 9.3 seconds, is it possible to be in 2 different places at the same time? Of course it's not. So at 9.3 seconds, you are at some height, and you are at 1 height only, and you will never be at 9.3 seconds again. Therefore, there's only one answer for that guy, right? So who's correct here? Afi is correct. Afi is correct. Does that help? Remember when I told you the other day people get mixed up with the one input has 2 outputs versus 2 outputs having the same? That's what I'm hoping that this activity is trying to, if you use a little bit of common sense and you can understand the difference between an input and an output, you should be clicking with this a little bit. Okay, here we go. Which of these equations has no solution? Look at all the different answers that we were getting here. Okay, here we go. F of c equals 0. Let's look at what this says. The f of c equals 0. They're saying, at what time is my height going to be 0? So the question is that ever going to happen? Yes or no? Look at your graph. Are you ever going to hit a height of 0? No, I hope not, because you'd hit the ground, and that would hurt on a Ferris wheel. So is there ever going to be a value of c that gives us a height of 0? I'd say no, definitely not. Okay? How about f of 0 equals c? Is that possible? Explain it to me, Charisma. What's going to... I don't know what's so funny, but explain that to me.
Well, the beginning point is through 8, so.
Exactly. What does 0 mean? Time 0. It's before we even started the merry-go-round, right? And you were probably sitting at a height of 8 when you got on your cart. The f of c equals 12. Is that ever going to happen? Sure it is. We already discussed it's going to happen multiple times, right? 2.5 seconds, 12.5 seconds. It'll happen again there and there and there and there, right? It'll happen many times. So it says, which of these has no solution? We said this guy has no solution, right? This guy's good. This guy's good. F of 12 equals c. Is that ever going to happen? Yeah, 12 seconds is going to happen. And at 12 seconds, there will be some height. So we're good there. F of c equals 300. Is that ever going to happen? No. That would be saying that at some time we're going to reach a height of 300. What's the highest we ever get? 12 feet, so we're certainly never going to get to 300 feet. So that one would not have a solution. And will f of 300 equal c? Will that ever happen? If we wait that long. If the ride goes to at least 300 seconds, then it would happen. So what are the two that don't have any solutions? I would argue that it's those two guys right there, right? F of c equals 0 and f of c equals 300. Yep. F of c equals 0 and f of c equals 300. Okay, comments or questions? Did that activity help? Did it make you more confused? For those of you that didn't do it, you best do it before I enter a 0 in the grade book for you. Okay, so here's what I want you to do now. Let's talk about domain and range. So go to your course docs and links on Blackboard. And if you scroll down to, oh boy, where am I? Section 1.2, there's two Desmos. Let's do the first one. It's called marble slides. Now, if you don't have fun doing this, then I don't know. These are kind of fun. So,
I forgot my computer.
you forgot your computer. Do you want to maybe just do it together? Never forget your computer. It should be attached to you everywhere you go. So you guys put two names in there for your name, okay? Maddie? Okay. All right. So are we on marble slides? This is as fun as it gets, people. Good thing you came to class today. One of you clicked on the free range solutions already, but we should be working on the marble slides. So, notice that our goal, did you guys figure out what the goal is? Get all the stars. It's like a game, right? So the first one is just a practice. They built a little funnel for us. You hit launch, it rolls out the marbles, you got all the stars, you're a winner. Okay? So what we're trying to do every single time now is we're trying to change the graph. Obviously, if I launched this one right now, it is not going to hit the stars, right? That's a loser, okay? So we're practicing several things here. We're practicing, we can change the slope and the intercept of a line. That's what we worked on in the last chapter, right? So let's say I wanted that intercept to be different. Let's say I wanted it to be -1 instead of +1. I could just retype it. That's still not going to do it. How about -2? That might do it. See what I did? But I could change the slope too. Let's say I want to change it to 1/3 instead of 1/2. You see what I'm doing? I'm manipulating the equation and it's changing the graph. So that's one thing that you can do. The other thing that you're going to end up doing is you can change the domain of a function. Change the domain, meaning right now the domain on this guy is all real numbers. It goes forever from -infinity to +infinity. But let's say, for example, I wanted it to stop. I don't even know how to do this. Let's say I only wanted x to be greater than 4. That didn't work. Trying to change the domain. Maybe I have to do it on a different one. I'm going to try number 4 here. What do you have to do?
No greater than and no less than.
Oh, so you got to do both parameters? Oh, here it is. Oh, you got to use braces.
I lied.
Yeah, maybe not. Do you see how, go ahead and do you guys see on step number 5, which is fix it number 3, do you see how they use brace, x is less than 4? And then look at that. Notice it stops. Everything's just less than 4. On the other side of 4, it doesn't exist. That's what we call restricting the domain. We don't want the domain to be forever. We want it to be a specific thing. So if I were to go back to this first one, if I wanted to restrict the domain for some reason, I go brace X is greater than 1 brace. There. See how I can restrict the domain? So you got to use your little brace, which is right beside your P button. Now for that one, I don't think I would even have to restrict the domain. It would have worked. But later on, you're going to see some examples of where you don't want lines going forever. You want to cut them off at certain places. Okay, I'll stop talking. It looks like everybody did fix it number 1 well, and a lot of you got number 2. Keep going. There's a lot of them. There's 20 some of them. There's 24 of them. So let's see how far we can get. You should be getting quick at this. And as soon as you get them all, move on to the next one. See if you can do it fast. Now, did you guys figure out that you can enter in another line and another line and another line? So you can make a bunch of different pieces if you want. So, like I'm looking at, well, this is Hannah's right now, but if I launch this is not going to work, right? I got one of them, right? So how could I fix this? I might be able to fix this with just the line that I have, but I might want to put in, say, another line down there, or two of them, or three of them, right? Some of you are flying, which is awesome. We're not going to spend the whole class period doing this. I want you to get through several of them. Is anybody struggling with how to make their domain, like cut it off on the left, cut it off on the right? Can you get it to be the size that you want? At the very end, I'll just show this guy. This is the last step. The last step is where you get to make a free play, and you guys can do this if you want when you get to the end. But this was me practicing a bunch of different functions And see all the different things I got here? I got a parabola here, a couple lines down there, a parabola there, a line there, a line there, a line there. And this is me being a math nerd. That was me just trying to drop a bunch of marbles into a bucket. Huh? Huh? That's what I do in my free time. Okay. I want to kind of stop where we're at right now. Some of you got much, much further than others, which is fine. What I'd like you to do is eventually get through all of them. So that'll be part of your assignment. And if you want to do the free play, you can. But I want you to get through step 23. Before we leave this, any specific questions about any of them? Anything that was stumping you, or you didn't understand the directions, or you just need more time to finish? Is that where we're at? Just need more time to finish? Okay. What I'd like you to do now is I'd like you to go to the second one, which is called free range functions. So remember, this section is domain and range, right? The domain is being able to restrict it because we were changing the x, right? We cut off some on the left or cut off some on the right or something like that. We were changing the x. This time we're going to focus on the range. So go ahead and go to that one, free range functions. So you already know this. Remember, domain is x, range is y, or f of x, right? So we were manipulating the domain. We were manipulating the x being greater than something or less than something. Now we're going to talk about the range, the y value. This one should go a lot faster. I'm going to pause you for a second. I want to look at number 2. Is 4 in the range of y equals x squared? Every single one of you answered yes, and the correct answer is yes. But I want to talk about your explanation why, because some of your explanations were good. Some of your explanations made no sense whatsoever. So this is where I want you to be precise about your language. So let's just read through this. It occurs on the y-axis. I don't know what that means. I don't think 4 occurs on the y-axis. The y input is 2 and negative 2, which produces 4. What's wrong with that? This is good except for what? Anybody? The y input? X. Yeah, it should be the x input of 2 and negative 2 produces a y value of 4, is what that person should have said. The line will go through 4. Okay. First of all, it's not a line, it's a parabola, right? So it's a quadratic, it's not a straight line. Will it go through, what do you mean by 4? It'll go through a line that is at a height of y equals 4, right? So again, we need to be more specific there. The range are the y values of an input. 2 and negative 2 both produce 4. That's pretty well explained, I think. That person. 4 is a square root that fits in the parabola. I'm not sure what that means. Yes, the 4, the y-intercept is within the parabola's range. I don't know if we're using y-intercept correctly there. It fits on the parabola. That's very generic. What is it? And what do you mean by fits? That's not mathematical language, right? The line reaches a width of 4 units. I think we're actually talking about a height of 4. So when you say the width of 4, that doesn't make much sense to me either. At one point, it does cross 4. You're right. It crosses a height of 4. It crosses the line y equals 4. We could be a little bit more specific there. The 4 on the y-axis is within the parabola. That is tough to read for me. I'm not sure what we mean by that. Yes, because the line will go through 4. Because the parabola will go through the line y equals 4. I know I'm being picky, right? But we want to use precise language. That's why this is asking us to explain what we mean by that. Okay, I'll let you keep working. Okay, I'm going to pause you briefly in the interest of time. For the Desmos, I'd like you to finish both of those. The marble slide one and then the free range functions that you were just working on. I do want to point out just a couple things from your textbook with domain and range. First of all, I made a little list of stuff right here. Okay? When we are trying to find the domain of a function, okay? So what we're really asking, when they say find the domain of a function, another way of asking that question is find all of the x values or the inputs that are part of the function or are allowed to be used as inputs, right? So from our movie example, find the domain of that movie example. Every movie whose title starts with the letter from an English alphabet. That would have been our domain, right? Except here we're going to be doing typically numbers, okay? So in general, when you see a function, you can start with the idea that every number works. From negative infinity all the way to positive infinity, you can assume that every single one of those x values is going to be a number that we can put into the function, okay? Except there's a few scenarios where we know we're going to run into a problem. Okay, and I just put two of those scenarios here, and this is all we're going to talk about for now. You guys already know that you cannot divide by 0. That's an illegal operation, right? So anywhere where your function has a denominator, like a numerator over a denominator, if that denominator is ever equal to 0, that means we're dividing by 0, and if we're dividing by 0, that's no good. Therefore, whatever the x value is that makes us divide by 0 is a bad guy. He cannot be in the domain. We would have to remove him, right? That's one area that's going to break our, assumption that every number works. The other thing we can't do is we can't take the square root of a negative number, right? Because that gives us an imaginary, an I, and we're not doing that. We're talking about real numbers with all of this, right? Okay, we also can't take the 4th root or the 6th root or the 8th root of any even root of a negative number doesn't work. But I can take the cube root of a negative number, right? Like the cube root of negative 8 is negative 2. That works. It's just the 2nd root and the 4th root, the even roots don't work. And then, of course, if we choose to, we can restrict the domain if we want. Okay? Like with the Ferris wheel, we restricted the domain. We didn't have f of negative 6 on the Ferris wheel because that would have been a time of negative 6. Well, time started at 0 on that. There was no such thing as time of negative 6. So that the domain on the Ferris wheel would have started at 0 and it would have stopped whenever the Ferris wheel stopped. Not beyond that and not negative time. So a few examples from your textbook. These are straight out of section 1.2 of your textbook. Think about this. You're given the function x squared minus 1 and they want you to find the domain of that function. What is the domain? Okay, let's assume that it's all real numbers. Negative infinity to positive infinity. And now we got to ask ourselves, if at any point am I going to divide by 0 for that first top one? Will I ever divide by 0? No, there's not even a fraction in there. So if there's no denominator and there's no fraction, there's no possibility of me ever dividing by 0. Do you guys agree? We're good to go there? Will I ever take the square root of a negative number? No, because there is no square root sign in this particular guy. So I'm going to avoid those two pitfalls. Do you guys agree? So what should the domain of this guy be? All real numbers. So there's a couple ways to write that. One way would be to write it in interval notation. We'd say from negative infinity to positive infinity, all real numbers. The other one, set builder, it would say all x such that x is an element of the real numbers. That's getting kind of heavier notation. I kind of like the interval notation. It just says from this one to this one, and we're good to go. From negative infinity to positive infinity. Okay, so let's look at example 3 in the book. It gives us a different function here. Okay, so again, we can assume, hey, it's going to be all real numbers. Go ahead and check. Am I ever going to divide by 0? No. I see a value that's going to cause me a problem, and I can do this one in my head. Which x value causes me an issue? 2. Do you guys agree that x cannot equal 2? Because if it does equal 2, On the top, I'm going to get 3, and on the bottom, I'm going to get 0, and 3 divided by 0, that doesn't work. Okay? Am I ever going to take the square root of a negative? No, there is no square root sign. So what is my domain here? It's every real number except 2. So how am I going to write that? Every real number except 2. Well, I can do interval notation. I'm going to go from negative infinity, and I'm going to travel to the right until I get to who? 2. I'm going to go up to 2. Okay, we talked about this before. Am I going to bracket it or parentheses it? I think we talked about this, didn't we? Parentheses. I get you guys in my other class mixed up. We did this, right? I'm going to do a parentheses because I do not want to include 2. I want to go up to 1.99999999999, and then I'm going to jump over 2, right? So I do not want to include 2. I'm going to stop right before I get to 2, and then we use this little capital U that stands for union. I'm going to jump over 2, and now where am I going to start again? Parentheses 2, and how far am I going to go? All the way to infinity. So that's how I do a jump over 2. I go right up to it, 1.9999999. I jump 2, and I start again at 2.0000001, and I move on all the way to positive infinity, right? So I got to have 2 pieces, and I union those 2 pieces together. Okay, how about the last one? Can you guys already see? Well, let's go through our thing. Are we ever going to divide by 0? No. Are we ever going to take the square root of a negative number? Maybe. What would cause me an issue? If x is larger than
8 or 7.
Even larger than 7, yeah. So think about this. Can x be 7 himself? Yeah, because 7 minus 7 is 0, and the square root of 0 is 0. I'm okay there. Square root of 0 works. So we know that x can equal 7. We're fine there. Okay. Can x be anything smaller than 7, like 6 or 5 or 4? We're good to go there. So where are we bad? Anything greater than 7 is bad. So if x is greater than 7, bad. Do you guys agree? So what is my domain? It's not if x is greater than 7. My domain would actually be from negative infinity all the way up to where? 7. Right? Now the question is, do I parentheses or bracket? Bracket, because I want to count 7. I don't want to go to 6.99999 and stop. I actually want to go to 7 and then stop. So I would go bracket, right? Now the other way you can test these quick, and we got 1 minute left, is you can always go to your graph, because the graph will tell you, right? Let's say I wanted to do that second one. It was x plus 1 over 2 minus x. I'll do x plus 1 divided by 2 minus x. And I spit out this graph. And notice that the graph, it looks like it goes forever to the left, all the way to negative infinity, forever to the right, all the way to positive infinity. However, notice it goes up, and then on the other side it goes down. What line is it never touching? What x value does it never hit? I think we said it was going to be 2. So if I put in a line at x equals 2, we said it was going to be every single guy except 2. Do you guys agree? So what should happen then is I put in that line at x equals 2. If I just kind of look at my graph, it's going to get really darn close to that black line, but it's never going to touch it. It'll never touch it. So you can see where that one goes. If I go to, let me just erase this one quick, and I'll hold you 1 minute late today. The square root of 7 minus x. XQRT, 7 minus x. Take a look at the graph of that guy. We said that negative infinity all the way to 7 is good, but notice there is nothing on the other side of 7. It doesn't exist on the other side of 7. So you can visualize the domain by looking at the graph, or you can just do the interval notation with the parentheses and brackets. It's two ways to look at the same thing. Okay, finish your two Desmos, and obviously you should now be working on your quizzes, right? Your 1.1 and your 1.2. Okay, see you on Wednesday.